All right, let's get right into it. Welcome to today's explainer, where we're going to be talking about confined spaces and the mandatory safety precautions that go with them. Now look, I know safety training can sometimes feel like you're just ticking boxes or pushing paperwork, but I need your absolute, undivided attention for this one, because mastering these protocols is, quite literally, a life or death matter for you and your team. In these environments, a single misstep, just a brief lapse in judgment, can turn fatal in seconds. So my goal today is to give you a crystal clear understanding of what these spaces actually are, the invisible dangers hiding inside them, and the absolute non-negotiable standards you need to follow to do the job and get everyone home safe.
So here's our roadmap for the explainer today. We'll start with defining confined spaces, move into categories and competency, identify the hazards, walk through safety precautions, break down the critical roles, and finish up with a safety summary.
All right, part 1, defining confined spaces. Okay, let's dive right into this. Before you can protect against a hazard, you've got to be able to accurately identify it. So what exactly makes a space confined? Well, for a space to be legally classified as a confined space, it has to meet 3 specific criteria. First, it's got to be large enough and configured in a way that an employee can physically fit their whole body inside to do the work. Second, it has limited or restricted means for entry or exit. You can't just walk through a normal door. And third, it's simply not designed for continuous human occupancy. It's not a place meant for people to hang out in. If your workspace hits all 3 of those markers, boom, you're officially in a confined space. And your standard operating procedures, they go right out the window. Just to give you an idea, let's look at some really common examples. We're talking about storage tanks, deep pits, grain silos, expansive tunnels, water wells, municipal sewers, and underground utility vaults. I want you to take a second right now and just visualize your own job site. Do any of these match the kind of infrastructure your team works around every day? Because making this theory immediate and relatable to your actual environment, that's the real first step in preventing an accident. Moving on to part 2, categories and competency. Now that we know what these spaces look like, we need to understand how we rank them. And more importantly, who actually gets to say, yes, this is safe to enter. What's really interesting here is how the severity breaks down into 3 distinct classes, and how the hazard itself dictates who gives the green light. For Class A, you've got your high-severity spaces. This is where we're dealing with gaseous hazards, like what you'd find in a boiler or a drainage manhole. Class B is medium severity. Think entrapment risks in places like bins or hoppers. For both A and B, clearance has to come from a highly specialized expert. Then you have Class C, which covers low-severity hazards, where a trained, competent person from your department working with a safety pro might be enough. But who handles the heavy hitters?
Well, that brings us to the competent person. And I really want to stress this. This isn't just the most senior guy on your crew. A competent person is an official expert, certified by the Chief Inspector of Factories under the Factory Act of 1948. They are rigorously evaluated on their qualifications, their experience, and their testing facilities. It's serious business. Only this legally recognized individual has the authority to examine the atmosphere, run the tests, and officially sign off that those high-stakes Class A and B spaces are safe for your team. Okay, so we've got our definitions and our gatekeepers. Now let's talk about what's actually lurking in the dark.
Part 3, identifying potential hazards. 19.5%. I really want you to let that number sink in. Normal, everyday air has about 21% oxygen. But if the oxygen level in your confined space drops below 19.5%, it is officially and dangerously oxygen deficient. And that drop can happen fast. It could be from rusting metal, organic stuff rotting away, or the oxygen just getting pushed out by another gas like nitrogen or carbon dioxide. Let's look at what actually happens to the human body when that number drops, because this proves exactly why continuous air monitoring is absolutely non-negotiable. At 19.5%, you're at the absolute minimum legal level to work without supplied air. Drop down to 17%, and your heart rate starts accelerating, early hypoxia. Between 14 and 16%, workers start losing muscle coordination, their perception gets fuzzy, and they get incredibly tired. Hit 12%, you're looking at blue lips and sudden unconsciousness without any warning. If you drop between 6 and 10%, it's nausea, vomiting, and an 8-minute exposure is 100% fatal. And if you go below 6%, a worker will fall into a coma with convulsive breathing in just 40 seconds, and death follows almost instantly. It's terrifying, right? And oxygen, or rather the lack of it, isn't even the only threat. Let's break the broader dangers down into atmospheric and physical buckets so we know exactly what we're facing. On the atmospheric side, sure, we have oxygen extremes, but we also have combustible gases like methane and incredibly toxic stuff like carbon monoxide and hydrogen sulfide. H2S is especially nasty because it's heavier than air and comes from decomposing matter.
Then on the physical side, you've got the very real risk of engulfment, getting buried alive, insane temperature extremes, electrical hazards, and mechanical killers like internal mixers or crushers that could suddenly turn on.
Which brings us to part 4, mandatory safety precautions.
Okay, so the risks are huge, staggering even, but they can be managed. Let's shift gears and look at the exact step-by-step process required to prep for a safe entry. Before anyone even thinks about stepping foot inside, you have to neutralize the environment. Step 1, ventilate, eliminate, or control the atmospheric hazards. Get some good air in there. Step 2, blind, disconnect, and cap all the input lines so nothing nasty can unexpectedly flood the space. Step 3, lockout/tagout. You've got to kill all the energy sources to any machinery so nothing turns on while a guy is inside. And step 4, the literal second you pop those entrance covers off, you have to guard the openings immediately so nobody accidentally falls in.
So the space is prepped. Now you test the air. You absolutely must test the permit space before anyone goes in, and then you keep periodically monitoring it to make sure it stays safe. But here is the critical, absolute rule. You have to test all levels: the top, the middle, and the bottom. Why? Well, because gases don't just mix evenly. They settle at different heights based on their weight. Like we mentioned earlier, hydrogen sulfide is heavy, so it's going to pool right at the bottom, while other toxic fumes might rise to the top. So taking a single reading right in the middle, yeah, that's practically useless.
Now, even with flawless prep and perfect air quality, things can still go sideways. That's where your equipment comes in as your final line of defense. We're talking mandatory full-body harnesses, the right respirators, whether that's a half mask or a full airline system, Tyvek suits to keep chemicals off your skin, plus gloves and goggles. And it doesn't stop at what you wear. Your team has to have rock-solid communication tools, explosion-proof lighting so you don't spark a fire, and emergency rescue gear laid out and ready to go before anyone enters.
Part 5, critical team roles.
You know, all the best gear in the world won't save you if you don't have the right team. Confined space entry is never a solo mission, never. It requires a highly coordinated crew with very strictly defined jobs. Let's look at the human element. First up is the entrant. This is the authorized worker actually going inside to do the job. They need to completely understand every hazard they might face and know their gear inside and out. But honestly, their biggest safety duty, aside from the actual labor, is constant communication with the outside. If anything feels off, if they spot a warning sign, or if an alarm goes off, they alert the team and get out. No hesitations, no just 5 more minutes. They evacuate immediately.
Then, stationed safely outside, we have the attendant. This person is the absolute lifeline for the entrance. They stay right outside the space, constantly monitoring what's happening. They keep a strict head count, they chase away anyone who shouldn't be there, and if things hit the fan, they are the ones who call in the rescue services. And here is the golden rule, folks. The attendant never, ever goes inside during an emergency. Actually, let me repeat that. They perform non-entry rescues only. If they go in to play hero, you don't have 1 victim anymore, you've got 2.
And overseeing the whole operation is the site supervisor. They are the ultimate gatekeeper for safety on the site. Their job is to verify that every single atmospheric test was done, that all the gear is in place, and that rescue services are actually on standby. Only after they've checked all those boxes do they officially sign off on the entry permit and let the work begin. And if conditions go south, they have the authority to shut the whole thing down.
Finally, Part 6, safety and compliance summary.
So we've covered a lot of ground today. We went through the definitions, the terrifying hazards, the prep work, and the team roles. Let's wrap this explainer up by looking at the big picture, because ultimately, the gear and the permits, they're just the physical results of a much deeper safety culture. Real worker safety relies on your ability to proactively spot these spaces and their hazards long before a job even starts. It relies entirely on comprehensive, non-stop training so everyone knows their role flawlessly. And finally, it relies on keeping honest, meticulous records. That paperwork isn't just busy work, it is the bedrock of a safety system that keeps improving.
So I want to leave you with a question, and I want you to answer it honestly for yourself. Is your team strictly trained on everything we just talked about? Are your site records, your testing protocols, and your emergency plans truly robust enough to guarantee a safe confined space entry tomorrow morning? Please don't wait until an oxygen monitor is screaming at you to find out the answer. Thank you so much for joining me for this explainer. Stay safe out there, stay vigilant, and always, always respect the hazards.